Hello everyone, today we're going to be going through the NSAA 2016 paper. We're going to be going through the physics section in this video. Every time I start a new question, I recommend you pause the video and try to do it yourself if you haven't done it yet. So this question, we only have to focus on the frequency and the wavelengths. We know that it goes from gamma to microwave. You know, you should have the electromagnetic spectrum memorized. You know that microwave radiation has a lower frequency. It has to be one of these two. And because all electromagnetic radiation travels at the same speed, you know that that wavelengths and frequency are inversely proportional. What does that mean? That means that if the frequency decreases, the wavelengths must increase. That case is going to be B. For this question, the first thing we should do is focus on the mass number. Why, you ask? Because beta radiation does not affect the mass number, it only affects the proton number. Only alpha affects the mass number. That means that if we focus on the mass number, we can deduce how many alpha emissions have occurred. We see that it's -4 in the mass. What does that mean? That means that only one alpha emission has occurred. Only one alpha decay. Why? Because every alpha decay means -4 in the mass number and -2 in the proton number. Because as we all know, an alpha particle has 2 protons and 2 neutrons. So that means that if one alpha decay has happened, the new thing should be like this. But we can see that it's 82. What does that mean? We need +2. And every beta radiation, that's 0 and +1. So if we need +2 now, we know there's going to be 2 beta radiations, 2 beta emissions. So 1 alpha and 2 beta. So it's this one. However, you see how I've calculated the beta. In the actual exam, you would not be doing this because first of all, you calculate how many alphas you need. Then after you see that, you look at the options. And once you look at the options, you realize that only this one has 1 alpha. So you know that the answer is going to be D, even without doing this, even without trying to calculate the amount of betas. And you have to be very careful with this. You have to look at the options at the very beginning because you don't want to be doing extra work. The Esat is a time pressured exam. All the difficulty comes from the time pressure. So you have to be as quick as possible. And the same way I'm writing all of this, you wouldn't be writing any of this. You'd only write the very basic. And in the physics section, there is very little writing in the first question because a lot of it is just a recall. Okay, for this question, this is just a purely recall question, and it's a very simple one to do. One key thing to remember is that the the rate of energy transfer is related to not the temperature, but it's proportional. Rate of temperature is proportional the difference. The rate of energy transfer is proportional to the change in temperature, the difference in temperature. What does that mean? For example, if we look at these options, see how here it decreases and here it increases. That means that the difference in temperatures between T1 and T2 actually increases. But for example, here it also increases by 10, here it increases by 20 degrees. Here it increases by 20 again. But here you see that it increases for both of them. So both T1 and T1 and T2 both increase by 10 degrees. What does that mean? That means that they're both hotter, but the difference between these two temperatures is the same. And since there is no change in A or L, it's gonna be H. The first thing we do is we look at the graph. The graph is a linear graph and the gradient is 5. The gradient is important. Here, kinetic energy against velocity. You know that kinetic energy is proportional to the velocity squared. What does that mean? That means it would be, if for this graph, it will be a quadratic, not a linear. So you know that 1 is not possible. 2. Potential energy against height for an object of mass 20 kilograms. Okay, this lifted by an external force does not matter. So it would be potential energy against height. That is a linear because you know that potential energy is mgh. But see, since this would be our x, our gradient would be mg, and mg, m is 20, so it's gonna be 20 times 20g. That would be the gradient, and that's clearly not 5. So 2 is not an option either. Now 3, velocity against time. Okay, for an object of mass 20 with a force applied of 100 newtons. So we know that acceleration is gonna be the force divided by the mass, which is 5. And acceleration is the rate of change of velocity. So we know that this is velocity against time. The gradient is gonna be the acceleration. The acceleration is 5, which is the same as this. You know that 3 is correct. 4, work done by an external force of 5 newtons against distance. You know that the work done, the energy, is equal by force times x, x being the distance. So since our distance is our x anyways, the force is our gradient, and the force is 5, which checks out with our gradient in the graph. So we know that 4 is also an option. Therefore, F is the answer. This question doesn't really require any understanding. It's simple math. You just compare the numbers. But something students forget to do is add this. You have to add these two and then compare it to all of this. For example, in this one, if we look at the mass numbers, we see that it adds up to 235, but it should add up to 236. So in that case, diagram 1 doesn't work. Here we see that it adds up to 236. So the next thing we do is compare the proton numbers. And we can see that the proton numbers add up to 92. So this one is correct. For diagram 3, we can see that this adds up to 336. So 235, sorry. In that case, you know that this is incorrect because it should add up to 236. So 1 plus 235. In that case, it's only diagram 2. So C. For this question, the first thing we need to do is see if we're going to use this, which setting of the variable resistor we're going to use. We want to maximize the power dissipated in resistor, in the 5 ohms resistor. To do this, we are going to have to maximize the current going through it. And to maximize the current, we have to minimize the total resistance. So we're going to use the 3 ohm settings. If, for example, it asks for the maximum power dissipated in the variable resistor, we would use 15 instead. But since it's about the 5 ohm resistor, we're going to have to use the 3 ohm setting. In that case, the total resistance is going to be 5 plus 3, which is A, so 8 ohms. We know that I, the current, is going to be equal to 8, not 8, sorry, 3. It's going to be equal to 3. This is 24 divided by 8, 3. Then we need to find out the power, and we all know that the power is equal to I squared times R. In that case, we have 3 squared, 9 times 5, which is equal to 45. When the switch is open, that means that this doesn't matter. This bit has 60 ohms and this bit has 30 ohms. So the total resistance of this is, so you know that 1 over R equal to 1 over 60 plus 1 over 30. But a trick that is useful to know is that if one of the quantities, if one of the resistances is double the other resistance, it's actually going to be 2/3 of the smaller resistance. It's going to be 2/3 of 30, which is equal to 20 ohms. So you know that the total resistance of this circuit is 20 ohms, which means that the ammeter reading is actually going to be 12 divided by 20. Okay. Then you have that when the switch is closed, and this is like this, we can ignore this resistance. There's going to be 30 and 30, which you know when you have two identical resistors in parallel, the resistance is going to halve. In that case, it's going to be 15 ohms. So that means that the ammeter reading is going to be 20 over 15. So in this case, what you have to do to find the difference, you know, first of all, that it's going to be higher. The ammeter is going to be higher. So it's one of these. You know that. Now you have to find out the difference. The difference is 12 over 15 minus 12 over 20. So the best way to do this is keep as fractions, of course, and simplify. So 12 over 15 you can simplify as 4 over 5. And here you can also simplify this as 3 over 5. Here you divide by 4, here you divide by 3. Now they have the same base. Now you can just take them away. In that case, it's 1 over 5, which is 0.2 amps, which is E. So for this question, they give us the formula we have to use. They give us then the initial power. Okay. So what we know is that by the end, the radius is going to increase by a factor of 100. So the new radius is going to be 100 times, so it's going to be 10R. And we know that the surface temperature will decrease by a factor of 2. It's going to be 1 over 2T. Then we just use the formula. We know that we have to square the radius. And then we also know that we have to do to the power of 4 for the surface temperature. Okay. So very simple. We know that this is going to be 10,000 R squared. We can ignore this actually, because we're just gonna have to focus on the numbers. And it's gonna be 10,000 over 2 over 2 over 2 to the power of 4, which is equal to 16. Then you can like simplify a bit. You can just go, and then you have to, before simplifying, know that you're gonna have to times by 4 times 10 to the power of 26. So first thing you can do this. It's 4 now. Then you divide 10,000 by 4, which of course is just 2,500. So in that case, you have 2,500 times 10 to the power of 26. In that case, you know that it's going to be one of these. And we're going to have to add 3 to the power. So it's going to be 20. The power is going to be 29. The answer is D. So this question is actually simple, but people get tricked by it. People usually try to find the velocity of it, and then they do like the velocity times the time, which is 1 minute. But that's not what's asking for, because it's not asking the total distance traveled by the wave. It's asking for the distance traveled by the particle. And a particle in a transverse wave is going to be up and down. That's how the particle is going to move. And the amplitude of that is 3 centimeters. And it's going to be 3, 3. This is a full oscillation of a transverse wave. So it goes up once, and it goes down twice, and then it goes up again. So it does 4 of these. So it's going to be 3 centimeters, which is going to be 0.03 times 4, which is 0.12 meters. This is the distance traveled by the particle in one complete oscillation. Because the frequency is 5, you know that it does 5 oscillations per second. So we times this by 5. In that case, we will get 0.6 meters. And we know that it's going to be 1 minute, which has 60 seconds. We do 0.6 times 60, we know that it's going to be 36 meters. And that means there's going to be 360 centimeters. For this question, we're going to have to find the tension of the block. So to do that, we have to use the acceleration. So a lot of people will do F equals ma and be like, oh, the acceleration is 0.8 and the mass is 5. So you do 5 times 0.8, which gets you 4 newtons. Of course, that's wrong. It's not gonna be that. This is way too little. We have to count for the weight acting on the block, which is 5g. We're gonna have to add 5g to our resultant force, to our tension, to have our tension. In that case, we know that T is actually going to be 5 brackets G plus 0.8. And since G in this question is just 10, we know that T is going to be equal to 54. But here lies the thing. You would say, oh, it's E, but it's not E, because it says what is the minimum tension force that the coupling must be able to withstand. But we know that the tension here has to be T. That has to be 54. So we know that. But the coupling, this coupling is gonna withstand T from this side and T from this side too. So it's gonna be 2T. So the actual answer is gonna be H. The options here are here to trick you. They give you these options, which some people may fall for, but most people fall for this one. But you have to be careful and look at the actual question. It's not asking for the tension, it's asking for the coupling, the tension the coupling must withstand. It's going to be double the tension the rope needs to exert. For this question, we have to calculate the charge and the voltage. We start with the charge because it's really simple to find. We have the time, so that means that to find the charge, we just need to find out the current. The current is really easy to find because we have the EMF of the battery and the resistance of the whole circuit. In that case, I is gonna be the EMF 6 divided by the total resistance, which is 15. Then to find out the charge, we just do I times time. In that case, it's going to be 6 over 15 times 3 times 60. This is 3 minutes. In that case, here we always leave it as a fraction because that way it's easier to calculate since the Esat is a non-calculator paper. So this is going to be 4, and then you have 6 times 3 times 4, which is equal to 72. You need to have sharp mental math skills because remember, it's a non-calculator paper, so you have to be really quick. Next thing we have to do is find the voltage. In that case, we have to find the power dissipated by the heater, the power of the heater. Because we know that it's going to be 180 joules. You know that power is going to be the difference in energy divided by the time. The time is 3 times 60 again, and 60. And this is just equal to 1, as you know. 3, 3, 3. It's just equal to 1. So you know that the power is 1 watt. You also know that power, dissipated power, is equal to VI. We already have V, which is 6 over 15. So you know that it's going to be the reciprocal of that. So it's going to be 15 over 6. And you can see that this is bigger than 1. And only one of these two options, since we know that it's going to be 72, we know that only one of these options is more than 1. So it's going to be F. The first step to solving this question is to find out the total volume of this shape. So to do that, we first find the volume of the cube, which is going to be 10 to the power of 3, because it's all in centimeters, just 1,000, minus the volume of this cuboid over here, which has a square face of 5 and a height of 10. So it's going to be 5 squared times 10, which is equal to 250. So in that case, you take away these two, you know that the total volume of this shape is going to be 750 centimeters cubed. We have that, we've established that. Then you know that the weight of the shape is 30 newtons. And since G is 10, you know that the mass is gonna end up being 3. So in that case, to find out the density, you have to do the mass divided by the volume. But notice how the mass is in grams and this is in kilograms. In that case, we have to convert this into grams. So it's going to be 3,000 grams divided by 750 centimeters cubed. In that case, that is equal to 4. Sorry, 0, 4, yeah, 4, which is F. Let's start by labeling this room 1 and this room 2. So the first thing we can notice is that all the temperatures in room 2 are the same. They're all 40 degrees. That means that there is no temperature gradient, which means there is not going to be any change in thermal energy by convection. What does that mean? That means that we can cross out all these options. There's not going to be R or S or this. Now what we have to do is look at the greatest rate of emission by thermal radiation. Radiation is the key thing here. So the first thing to notice is that black bodies absorb the most radiation, but they also emit the most. That's how black bodies work. So because of that, that means there's going to be either Q or S. And here we said that because there is no temperature gradient, there's no overall change in thermal energy, but the rate of emission of thermal energy is fully dependent, for a black body, is fully dependent on the temperature of the body. So the hotter the object is, the higher the rate of thermal radiation. So that means that the answer for this is going to be S. S here, going to be D. Here we have to calculate 3 different quantities. The first thing we should calculate is the total distance. So for that, we just have to add up the areas. So here this is a triangle of height 8 and base 20. So that's going to be 8 times 20 divided by 2, which is just 80. Really simple. In the exam, you wouldn't write this. You'd probably just write the 80. Here, very simple again. Height of 2, base of 10. That means it's going to be 10. So the distance traveled is going to be 90. Then the next easy thing you can do is find out the average speed. So the speed, you know that the total time is 30 and the total distance is 90. So it's going to be 90 divided by 30, which is equal to 3. You know that it's going to be one of these two. And then for the total, sorry, that's it. And then for the distance from the starting position, you have to do this distance minus this one. So you know that it's gonna be, but you don't really have to do the calculation, though it's really easy because you have the numbers here. So you know that 70. It's gonna be one of these two. It's gonna be A. But if you had harder numbers and you didn't want to calculate it, you'd only have to know that the distance from the starting position, which is the displacement, is going to be less because you have a portion of the graph that's underneath the x-axis. It's going to be less than the total distance traveled. So you know that it's going to be one of these two. in case you had like more difficult numbers and you wanted to save time by not doing the calculation. The first thing we notice is that it says that initially only x is present. That means that we can cancel out this one from the very start. The next one we can say not for sure is c, because you can see here that the quantities x and y seem to always add up to the same around here, which indicates that y doesn't decay at all, which is not the case. We know that y is also radioactive and it also decays, so it can't be c either. The next one we can cancel is d, because in d we can see that the peak is too low, too early and too low. This would indicate that y has a very high activity, but we know that that's not the case because the half-life of y is actually double that of x, so the rate of decay should be much slower than that. We know that it's not d either, so it's either a or b. Now, we know that it's not b either because this peak is too high. It doesn't make sense, because if we add up these two quantities, we could see that it's actually higher than the initial one. You can see that this would indicate a total of around here, which is not possible since x decays into y, but y also decays. That means that the total number, how we said in C, has to actually decrease. So it can't be B either. So in that case, the only option left is A. The total mass of the sample, we're gonna call capital M, is 10% by volume, 10% tin. Tin is Y. It's gonna be Y plus 90% copper, so 9x. That's what we know. We could put 0.1 Y plus 0.9x, but it doesn't matter. This makes it easier to work with. Okay, then we know it's asking what the percentage of the mass is tin. So we know that the mass of tin is just Y. So the percentage of the mass tin would be is equal to Y. It's gonna be Y plus 9x, and then we just times by 100. So why is that? That's clearly G. We know that momentum has to be conserved. That means that the momentum of this big particle is gonna be the same as the momentum of this particle. And both energies, both kinetic energies, add up to E. What does that mean? Since the mass of this particle is so much larger than the mass of the alpha particle, that means that the velocity of the alpha particle is going to be much, much larger than the velocity of this big particle. So in that case, that means that since kinetic energy is proportional to v squared, we know that the kinetic energy of the alpha particle is going to be massively larger than the kinetic energy of this big particle. So in that case, you know that this can't be true. And so it's gonna be D. And why is it not E? Because this particle will still have some energy. Of course, it can't, the alpha particle can't contain all the energy. So the clear answer is D. And here you can notice that we used qualitative ideas and we used zero calculations. This can be done by calculating. For example, you would know that if we call this V, then the velocity of the alpha particle is actually going to be 234 divided by 4v. Then you can calculate the kinetic energies from these and then like compare it to E. But we don't have to do all of that. That's a waste of time. We can talk about it qualitatively and realize that the only possible answer is D. And that's what you should do in the exam, is you have to save time. So the less you write and the less calculations you do, the better. The first step here is to calculate the distance from the speaker to this building over here. It's going to be 128 minus 48, which is just 80 meters. But then we know that the distance traveled and the sound wave is going to be double this. Distance traveled here is going to be 48 times 2, which is 96, and here is going to be 160. Then you can calculate the frequency at which the sound waves hit loudspeaker, which is going to be the speed divided by the distance. The speed is 320 divided by the distance, in this case is 96, which we can simplify to 10 over 3. In that case, 320 divided by 160 is going to be equal to 2. We have 10 over 3 hertz and 2 hertz. And from this, we have to find out the lowest common multiple between these two, which is clearly 10, because it has to be multiple integers. If we times this 1 by 3, we get 10. If we times this 1 by 5, we get 10, only 10.